Hello, numerous audience. I am Pietro. Yeah, I've been in a bunch of teams lately, so whatever. But I've been for a long time in the Charm Tech team here at Canonical. And I wrote this presentation when I still was there. So forgive me if I say things that no longer apply. But this presentation is about charming DevTools, and well, the starting point is CharmTech, or the team that I was in. The main task was to maintain the operator framework, which is Python lib, that library that people use to write charms with, and to maintain or contribute to all sorts of infrastructure that people use and need when they do charming. So think about everything working with Juju, Pebble, Charmcraft, and documentation. Secondly, I contribute to a bunch of charm libraries, operator lib Linux, rolling ops, harness extensions, so stuff for testing charms. And delivered support to charming teams, internal and external, wherever needed, just trying to be helpful. And I also started developing at some point charming tools, which is what this presentation is about. When I joined Canonical, I wrote my first charms. I followed the first tutorials, and I realized that there was a gaping hole in the middle of the ecosystem, which was tooling around the development and debugging of charms. I wanted to have something at my fingertips for debugging, introspecting, hacking around, doing manual testing, so the fun stuff, let's say. And eventually, I started writing a collection of Juju hacks, shortened as jhack, even made a logo. And this is, I think, the morale of the story. It doesn't need to be perfect. It just needs to kind of do the job. This is a disclaimer that this is a testing and debugging tool suite, which started as a very personal project, and then at some point, people saw it. Oh, cool! Can I have that? So I made it more or less public, but it's very hacky experimental tooling, so please do not use it in your production cloud, or if you do, don't ping me. It's not an official Canonical tool yet, until I can find more people to help me maintain and expand it, so I'm hiring. And the best outcome for jhack is eventually to become redundant, and the parts of it that we like, the parts of it that are most useful to all are moved into Juju core, and or Python lib Juju or whatever, and the rest is discarded. Now let's talk a little bit about the charming development flow. What do you do when you develop a charm? So. Typically, you start with an idea, so like an application that you want to charm, or like something that you want to implement, or a feature that you want to add to an existing charm. And then you go over to writing some code, writing some unit tests, iterate between the two as needed. Then you deploy to a local testing cloud. And finally, you write some tests, integration tests, because those are lengthy and expensive to run and just expensive to maintain. So that's kind of usually the last thing you do. There's another scenario, which is when things go boom in production or in development. There's a problem. Then again, you try to reproduce it on your local cloud, microcates or whatever you have. Then you write some regression tests to catch it in the future, you fix the issue, and then you go back to releasing. Now, the part of this flow which I'm most interested in is the hacking around in the local environment, in the local cloud. So you are on microcates, you're deploying your local charm, maybe from CharmHub, maybe just from your local code base, and hack around, play with it. Now, for the many of you that are following from home, if you want to be able to do the stuff that I am about to show, you need to install jhack, which you can do either from sources, or there is a snap strictly confined since a couple of weeks. And you can copy these commands, paste them in your terminal, to obtain the setup that I have here. Can you see that? I hope so. There is a Juju model with 2 units of Prometheus, 1 unit of traffic, and they're related. They're pretty simple. So this is, like, I develop traffic, so I find myself often using traffic as an example because I know it very well, but whatever charms you are developing, the procedure is going to be the same. All right, so let's start with the tour of jhack. So the tools that are in there that can help you in your daily charming. I categorize the stuff in jhack in 2 broad groups. Tools to see things and tools to do things. The tools to see things are about revealing some data which is in Juju but is hidden or not, say, very accessible from the, say, Juju CLI commands. So as you know, the Juju model is top-down, consists of a bunch of clouds to which you bootstrap controllers. In each cloud, you can have multiple models, models that have applications, applications which have, depending on the scale, multiple units. Between applications, you have relations, and if the applications belong to different models, they're called cross-model relations, CMRs for short. When you run Juju status, that is pretty much what you see. So you can see easily the controllers. You can easily see the controllers that you have, the models, the applications you have, what scale they have, and so on, and the relations that are there. What you not really easily can see, and what when you're doing something that when you're doing development of charms or debugging you would really like to see, is the events that are being fired on the charms as the deployment progresses, or as just things happen with Juju. The status, or let's say the state of the relation data, and the stored state that a charm has. So these are all things which are there somewhere in the Juju database, but which are not easily accessible if you're just running the Juju CLI. So the command that I have running up here is jhack tail plus a bunch of flags of traffic 0. So what this command does is essentially it parses the Juju debug log and filters out those logs that pertain to specific events. Not sure why it's not. Sorry?
Sorry, I haven't used jhack tail before. Cool. What are those flags?
All right. R stands for replay. So it's telling jhack tail to not just start listening now, but to actually dig up the whole history to find out since the beginning of time what events have been fired on the unit. The D stands for deferrals. So it's going to show the deferrals. So if an event gets deferred, you're going to see a little symbol. If an event gets undeferred, so remitted, you're going to see another symbol. So it's useful for tracking what events are deferred and what not. So you can see even there's a little counter there that shows you how many events are currently deferred. N stands for, to show the event number, which is an internal operator framework counter applicable when there is a deferral. So like each deferred event gets a unique number, and that is going to be showed in the log. And L is for the length of the history. So if I do the L 100, I'm going to show the last 100 events, except for some reason it's not catching them. Oh, because I'm in COS. Okay. Yes. I was on another model. Okay, just to see some events come up. Exactly. So I just removed the traffic ingress per unit relation, and you see them come up in traffic 0. So in the tail. And if you omit the target unit, you're going to see all of them. Yes, that is jhack tail, and that's useful for just watching the events in real time. And yeah, like especially as a beginner, it's hard to understand which event fires first. Why did I get relation changed before I got Pebble ready and whatnot? So this is really an easy way to see exactly what happened in real time also, just to tail stuff as it happens. Another very useful command is show relation, which is a tool for visualizing the raw relation data. So as you know, charms can be integrated or related. And as part of that relation, the charms get to write in their application and unit databags data that then can be read by the other side of the relation. And when you're developing a couple of charms or a bundle, like in this case, it's useful to see what exactly is in those databags. So if I run jhack show relation, W is for watch, and N is for essentially pick me the number 1 relation in the status list. So an alternative for the N is to just say traffic ingress per unit from ingress. Which, let me show this thing. So this is the application data that is in the databags. So you can see that there is, it gives you the relation ID, which is an internal thing, but yeah, like it can be useful sometimes when you're running commands. And you see the 2 applications, Prometheus traffic. You can see the relation name, the interface. So that's the same stuff you would see in status. But then you also see the application data belonging to Prometheus, the unit data belonging to Prometheus. So that's this stuff. And the same for traffic. And this is on a watch. So for example, traffic, you can see that it has configured the external URL foo.com. So if I were to do traffic external host name hello Ubuntu Summit.org, I'm going to see a couple of events come in, and data bag has changed. So that is just useful. I think you all can see how it's useful. But yeah, when you're debugging relation interfaces, it's very useful to see in real time how the data changes. Like this is all data that is there, but it's somewhat hidden. So you would have, in order to see this data, you would have to run show unit traffic 0, and you would see the application data bags, not of traffic, but of Prometheus, which I found very confusing. I like to have things a bit more, this belongs to me. So it's a different view on the same data, but I found it more intuitive. Oops, what is this? Yes. Very similar command. It's about not showing the relation data, but about showing stored data. So as you know, in the operator framework, we have a thing called stored data, which you can use to essentially store some state on the charm that gets persisted across charm executions, regardless of whether it's good or bad practice to use it. There is a command stored traffic 0. This is going to show you the contents of the stored data. So you can see the current external host, which is the thing we just configured, routing mode, path, TCP entry point, and so on. What I like about this tool is that it uses the operator framework handles, which is kind of an internal construct, but it allows you to see at a glance where is this data. So you can see here that it's the traffic ingress charm underscore stored. So if you were to go to the traffic gates operator code, this is exactly, so it tells you exactly where that stored data is. And if you know that there's something wrong with it, then you know exactly where the bug is, or at least how to start searching for it. Now, second category. This gets a bit hackier. And it's about tools to do things, hopefully better, or otherwise just in a different way. There is a tool called jhack Fire, which is about simulating events. So when I joined, the charm development flow was make your code changes, pack, refresh, run, see some debug log output, and then go back to writing some code. Debug code, debug hooks, sure, there are some facilities for going in the charm and seeing live some more stuff, but there was no way to easily simulate an event. The pro charmers would know that there is such a thing as Juju exec, traffic 0, and then you could do stuff like something like run hooks / update status. So this is something you can do in reactive charms, for example. It's easy to just execute execute a hook by running an executable. And this is basically what jhack Fire is doing under the hood. But I think this is in combination with sync, jhack sync, it's another command, enables a new workflow, like a much faster workflow for developing and debugging charms. So sync is a command that essentially watches a local charm tree package structure for changes and pushes whatever changes it can see to a live unit. So if I were to do to run this command in my PyCharm or wherever, it doesn't need to be in an IDE, but if I were to run this command, I could see a bunch of warnings, and then whenever I make changes to the charm, it's going to say synced, and this code is now live on this unit. So let's give it a shot. I save it, it gets synced. That also works for charm libs, by the way. Yes?
Does it sync to all of the units that are deployed?
I believe
traffic is just one unit, right? But
yes.
If you were to sync with Prometheus, would it sync all of the units?
I don't think that feature is there yet, but at the same time, it's really easy to add. Let's see. Yeah, it might actually work already, but I never tested it yet because I usually, traffic is always scale 1. But it should work, I think. Otherwise, it's really easy change. Sir, go on.
I had a question about the last thing that you did with simulating events.
Mm-hmm.
What if you what about events that are more complicated that pass in some data? For example, relation departed will have some information in the event itself. Mm-hmm. How would you pass that in?
So that is exactly why executing the charm with just Juju exec is complicated, because you would need to set a bunch of environment variables that tell the operator framework what relation we're talking about, so what relation ID it has, and so on. while jhack fire does that for you. So it queries the model to list the relations, the relation IDs. It fetches the right relation based on the relation name. So if I do jhack fire traffic 0 ingress per unit relation changed, based on the name ingress per unit, it knows what relation to look for. It fetches the relation ID, and so it populates the environment variables with all of the data needed for the charm to actually run.
Follow-up. What if you want, this might be like too specific, but let's say you wanted to simulate changing the IP address. Changing the IP address of a unit does trigger a relation change, or a unit changed event, peer relation changed. Can you pass in specific values? I guess is my question.
So,
when simulating,
like, what values are, like, the contents of the databags, you mean?
So,
or what values?
I think the answer to that question is that information comes from relation data.
Okay.
Which is sort of outside of the event.
Okay.
You get, right?
Yeah.
Yeah. So, like, what we're doing here is we're not mocking or simulating any of the Juju model data. So we're doing nothing with the hook tools. So whatever hook tool is called is going to really get called.
Okay.
So if you trigger a charm execution that screws with the Juju model, you are really screwing with the Juju model.
Mm-hmm.
So if I were to simulate, like, ingress per unit relation changed is innocuous. It doesn't do anything. Like, it just, refreshes the config. But if I were to do relation removed, then the charm would likely clear its configurations and put itself in an inconsistent state. So that is why, like, in theory, if all the hooks are idempotent, which they should be, this is not an issue, right? Because you could just do removed, changed, and it would just know exactly how to handle the situation. Yes?
In the example that you just ran, you didn't specify the unit ID or anything.
Yeah.
What happens if you have if you're related over that interface twice?
So if you want to know,
like, if for
which one,
if for example there was a Prometheus there, but there was also like a Loki related over that same interface.
I think so. Like, yeah. In this relatively simple case, there is no ambiguity because the charm only has one relation on that endpoint. There are, like, you can pass in, you can override the environment variables from the fire command.
So, like,
But I don't think that I did any smart selection for filtering out what remote, or maybe I did. Wait, let me check.
like, would it just pick one?
Oh yeah, nice. So there is a relation remote which defaults to, like, if there's only one, it's that one. Otherwise, you can pass the name of a remote application to essentially, disambiguate which relation is changed. Yeah. Nice. Surprised myself. All right, I don't have a lot of time left, so yes, what I wanted to say that could be really useful for folks trying this out is that the combination of sync and fire can be really, really powerful. I use that a lot because if you go and do, I don't know, let's do something easy. So update status, and yeah, I already had it here. But so, and let's say that I change something in here. Debug. Hello, folks. I save it. This is gonna sync it. Then I do update status. And then I'm gonna see, so like the charm is going to execute with the code that I just modified. So this enables you to have really, really quick iterations instead of repacking, redeploying, whatever. You just go change the file, and fire the event. And yeah, as a boon, it also appears differently on the tail to let you know that it's not a real event; it's an event that you are simulating with Fire. There is another slightly more convoluted evolution of the same concept, which is replay, jhack replay. That is a work in progress, not entirely complete. But the idea here is that we're doing more than just simulate. So like in jhack Fire, I'm putting together a synthetic environment from scratch. So I'm just executing the charm and telling it, this is your environment, I provide it. While in replay, what we're doing is we're capturing an environment during a real execution, storing it to disk, and then later using it again whenever we want. So we are storing a real environment and reusing it instead of creating it. And additionally to the environment, so like the environment variables and the context that the charm executes in, I also intercept all of the hook tool calls that are made. So the charm reaching out to Juju to extract, like, I don't know, the relation data, or leadership status, container connectivity, so even Pebble calls. I capture all of that, serialize it, and put it in a database. And then later, whenever I want, I can replay the charm in that exact context, even if the context has, in the meantime, gone. So if I do jhack replay install on traffic, this is making a bunch of changes, is rewriting the ops source with the AST module, so it's really hacky stuff. But now the recorder is installed. So if I fire on traffic 0 update status, or even if I do, oh, nice, you can see the defer. So this event was deferred and immediately consumed a couple of seconds later. I'm going to nuke the relation. I'm going to re-relate them. You can see a bunch more deferrals. And now, let's look at the database. We have captured a bunch of events, an update status, departed, broken, created, joined, changed. So these are all events that we have serialized and that now are present in the database. I can do dump traffic 0, 0 to see the content of that update status event. So you can see that there's a bunch of stuff in there. For example, these are the responses to the leadership checks. So this is the charm asking to Juju, am I leader? And the answer is yes. These are Pebble push, I believe, pull. So these are serialized bytes files that Pebble is sending to the charm. What we can do once we have this is we can init. So during this call, the charm is, this is normal, so it's all cache hits. So this is essentially the replay runtime telling to us everything is fine. The charm has sent this request, but we have it cached because we're running from that database, so we don't need to actually forward the call to Juju. The nice thing about this is that you can do post-mortem analysis on borked charm hooks executions, because suppose that I now remove the ingress relation. Suppose that I nuke prom. So like Prometheus is completely gone. Now I can, like, those events are still in my database, So suppose that something weird happened on that specific ingress per unit relation joined event, which is number 5. I can replay the charm in that environment, and the charm is going to be executed exactly as it did back then, even though nothing of that context exists anymore. The remote end doesn't exist, the relation data is completely gone, but you get to replay the charm exactly as it did back then. So what you get is fully repeatable charm executions, which is awesome. Like, think about injecting this into a CI. Something breaks. Right now, you just have the logs. You have no way to reproduce the bug. And something which I really hope to also soon do with this is, and then it's already working, but I'm out of time. You can dump the database to a local testing folder, and then you can use that as backend to run the charm locally. So you can run the charm without Juju running, without anything running except for PyTest, and the charm will behave as if it was deployed, because it's going to get Pebble responses, it's going to get hook tool responses, and so on. So we're going to mock everything without having to write a single line of operator framework harness code. And that was it. I'm out of time, so get charming, get jhacking, and check out other jhacks. There's a bunch of stuff I didn't touch upon. Provision, nuke, you have seen a couple of those. And most of all, have fun. And I'll close with this slide.